Here's the machine trying to meet the request for me to have Kubernetes backend be reverse engineered. Now, while it would explain that it's tedious and may take several attempts, it can be done. Thus far, what you're seeing is it describe a way to do the equivalent, which just interfaces with Kubernetes. Now, I've told it not to use PyKube, but instead Kubernetes Python client. And the reason to use Python Kubernetes client is for better organization and better usage of the same sets of information that you would use a YAML file for. The reason is you don't need a YAML file, or at best, you can adapt it to this solution. And that's the entire point, is that you don't necessarily need to use it the way it's intended to use at all be used. In fact, you don't even have to know how to use half of it to have it simply stood up like this. The simple way. Now, there probably is more things that one can add, like, say, a domain name. Now, what it's supposed to be doing is writing code to basically do the thing I requested. Give me a domain name, one that uses a top-level domain. But make sure it only uses the same interfaces that Kubernetes and Python would be using. In this instance, it interpreted that as using the same Kubernetes client backend for Python. As you can see thus far, most of it's pretty basic configuration and pretty basic templating. Now, realistically, you could create a small basic .conf that does the equivalent configuration and parsing of this information. You could even make it the equivalent .toml file, and it could be used to do the same thing, including all of the load balancer configuration. Now, not only do I have deployment status information that I can get back from it, I can also have it stand up using that external name. And if you're using OpenSSL document signing, you can use it with a Flask server. Hey, look, you have a public domain. And if you're using anything I put on ChatGPT Solutions inside of GitHub with this, namely the modified version that uses Flask and libDNS, you can practically host your own website, mostly in Python, but barely targeting Kubernetes. If you try even harder, you can get the pod after it's spawned to a deployable state, or from the deployable state, all of its input and output to everything, everywhere, anywhere it runs, in every process included, and have it mapped to your local device under a separate /proc directory of its own. You can even call it proc2, so that the two /proc trees don't get conflicted, manipulated, construed, or broken. The last thing you would want to prevent, besides that type of mechanical failure, is everything being compatible and it all breaking your systems, because it's compatible enough to match similar, if not the same, requests, because it doesn't have the proper namespace separation. The one thing this solution does not include in it is a way for all three containers to be aware of each other. The only thing that's aware of each container, and vice versa, is the load balancer. And the load balancer doesn't know how to check based on a single cookie which server they were using last, and how to revalidate against that same server. If you're using WebSockets, the problem becomes none of them can talk to each other because they don't know the IP of each other, the name of each other, or even if they know those two things, how to communicate effectively over those tunnels because the ports aren't exposed. Or if they are exposed, the API is being misused, which is the other potential. The other potential is that the same setup can be done within 4 Docker containers, but using one Docker and Docker solution, and still using all Python code to do the equivalent of this. The only piece that needs to be reverse engineered from this in reference to Kubernetes is how it does the overall service provisioning part, and how it does external namespace listening for top-level domains. Otherwise, 90% of what Kubernetes is used for can be done with Docker. Docker, a Google spreadsheet, Flask, and Python interfaces over JavaScript. Beyond that, Kubernetes is not really needed. It's a fun toy. I guarantee you. It has plenty of valuable and fun uses, but it can be done simpler and better, and it should be. That includes reverse engineering solutions like this, picking it apart until there's just the needed part to solve the actual problem, not all the bloatware the solution comes with. And currently that's what Kubernetes is, a lot of bloatware for the little bit of oomph the solution gives you. And that's just describing the overhead